will get to know that probing is done on the device or not. So once you get closer to the device, your probe will go and touch your device metal pad. So once it touches metal pad, till then your probe will move straight. Once it touches that metal pad, it will start moving in this forward direction, okay, lateral direction. So once you start moving in the lateral direction, that means your probe is touched your metal pad and the probing is done. The other way to check is these are the triaxial connectors. Will be having three parts that inside the metal one, then this will be insulating one outside and the carbon shield guard will be there in the middle part. Okay, so you can take multimeter and once you've done the probing, you can take the both triax connectors and you can see whether your short is happened or not. If short is happened successfully, then your circuit is closed. Then you can go for characterization. Okay. These are the BNC connectors. You can see the difference for both tracks and BNC connectors. So these BNC connectors will be helpful whenever you are providing any backdated connections. Okay. So yes. Yes. So every micropositioner having the three positions, you can move up and down, left, right. You can move front and back. Similarly, this chuck is also rotatable. Is it clockwise or anti-clockwise? And you can move front and back also. Depending on then you can start focusing on the pads first, metal pads. Okay, you have to adjust this microscope, video-based microscope. You have to adjust and you have to give the as much as best resolution of the metal pads so that you can probe them. Mhm. And these micropositioners also are not supposed to leave directly as a magnetic based micropositions. You are not supposed to place hardly on this plate end. So you have to tilt this, you have to place it on tilted position, then slowly you can make it down, you can bring it down. Or else it can have some mechanical movement inside there and it can damage the position. So always whenever we are dealing with the microscope or any checks, whenever we are dealing, we have to deal with the plastic pieces. But whenever we are dealing with any chemicals, then you have to go with the metal pieces because plastic can is a any of polymer also, so it can dissolve in the chemical. So you're not supposed to use whenever you are using the chemicals. Okay. So now we can first verify these. These are the four holes they have given. Corresponding vacuum switches has been given here S1, S2, S3, S4. Okay. So you can turn on the particular vacuum S1 which is at center. So once you turn on, then you can verify whether the vacuum held the sample or not. I'm trying to move the sample, but it's very hard to do. So that means held by the vacuum. Here to focusing it will take a lot of time. There is one software that is associated with this microscope. This is the digital camera. Everyone can come this way. This way you can. Okay. Visual screen. Yes, okay. Maybe we can adjust so that.
तो वो आपको इस माइक्रोस्कोप से नहीं है, नहीं ये नॉर्मल डिवाइस में माइक्रोस्कोप। हाँ वही चीज़ मतलब इसके यहाँ पे पतला सा एमओएस का स्ट्रिप है एक्सफोलिएटेड फ्लेक का।
Whenever we are moving the limits up and down. So one of them will be the master recipe, one of them will be the slave recipe. Because we want to control all the things through software. We don't want every time we have to come put some values, check meter values, voltmeter values, because this will only show you the values. So software you can collect the data, then you can plot also, then you can do different types of sweeps also. Like if you want to do transient analysis. So through here it is
little bit difficult. But in software there are already pre-made checks also. And for transient analysis, you can give the initial voltage, last voltage, and the step size that you want to give. So we will connect. These are the GPIB connectors. So both the SMUs have GPIB pins in their back. So one of them will be master, which will be connected through a different cable to the computer, and the slave will be connected to the master. So whatever you are doing here, you will give instruction to the master. Accordingly, master will connect it to the slave. So since we have 4 probes here, for 4 probes we need at least 4 connection of the SMUs. So each SMUs have the similar connection, similar type of configuration in the front and the back. So this will be SMU1. If it is master, it will be considered as SMU1. At back you can also see there is similar connector SMU2, 3 and 4 in the software. In the software you will not see master and slave. You will see SMU1, 2, 3, 4. It will be the order, like if it is master, it is slave. You can connect one more slave here, slave 1, slave 2, you will assign like that. So then you will open the keyset connection export details software to verify if all the SMUs are connected in the order that you have defined. So at the time when you are initializing the SMU, you have to give a GPIB ID, which has been already been provided. For the master we have given 22, and for the slave we have given 24. It is given physically. When it will be moved, you can change it. So like if you want to know how to change that, then you can read the manual. It is a different process. Once you have assigned, then you connect, like you have assigned 22 to this, but you are giving master connection through that, then it will not verify. So you can change here, like if you want, you can change the GPID primary address here. Okay, if you want, then we can test the connection. It will check and say, okay, the GPID IDs are verified. This is the 22. If you go here, you can also verify it. You get test connection. It will tell verified. And once these two are connected, you can run a overall check to see if all the connection that we have done, the computer to the master, master to the slave, has been done correctly. So if you run it, it shows these address that 22 and 24 for this one, 22 for this one, it has been verified. So after we have done the verification, see, I have to see the verified, it will run again, it will be verified. So if I will change the values, it will not show the verified values. Okay, the connections are done here. Software part is done. Yeah. Okay, you can come one by one. Let's remove the external one. One person can come. You can move to the microscope. You can move the person. So connected. Yeah. Yeah. I just connected only on the one metal there. So when you come here, try to see from this point of view, you can see so we touch your every substrate. Okay, then again, as I told you that how to check it, so you take a multimeter and you can go for the short circuit. Okay? So I am touching to the metal which is present inside this galaxy of cable. And to this. Say it is sound is not, it is short. That means our probing is done properly. Yeah, these are triax connectors, right? So inside there is a metal connection. So since we have connected our probes to the same metal, so if we are connected to probe tips to the same metal means it is like a closed connection. So how we will ensure that whether our probe tips touched our metal pad perfectly or not? Okay. So that you can go with this multimeter short check. Go for this metal tip. You can touch this. It comes, then it's a short. Then once it is short, then you can see. So okay, based on device, single to metal pads are there. So depending on your device, your metal pad size will also be different. Basically, they will make 100 micron metal pads or 200 micron metal pads. So depending on that, if you are going for a smaller metal pads, then you have to use bigger tungsten probe tips. If you are going for if you are going for smaller, then you have to go for bigger tungsten. If you are making a bigger metal pads, then you can normally use smaller 10 micron tungsten tips like that to probe the device. So one person can start with you. Okay.
You are saying for
bottom gate, I will have to connect to like.
yeah, you have to give the supply to this chip. From this chip, it will get into the back side of the substrate, and then it will act like a back gate. So it can come. Yeah, it will.
For frame side, bottom gate is there. Here we have to apply like bottom gate and two contacts.
Yeah, these two are partners. These two will be acting like the source and drain circuit, and bottom is bottom. We don't support on this normally see through the microscope. You can see the probes. You can observe here. So it's this cross section you can see. So let's say I'm just I just want to have everyone in the microscope it will take a lot of time to go. Yeah, I'm not doing device calculation. I'm just showing how light will be shown through SMS and how the probing is done. You don't see the material. If you go high objective microscope, then you can see the material also. Okay, what they will do, they will just make some thin connections. Okay, this thin you can see. Actually, just focus. So in the system, if you see, in the system, if you see that full screen, so in the system, if you see that there is a thin line here. Right? There is a thin line. So your actual material is there here. Okay. So what they will do, they will just make some thin line. Okay. After making the thin line, they will just make this and they will make the bigger, larger pads. And they will apply the voltage to this pad. Okay. Why it is? Because
all the spots.
In the line of in that line, particular line, they are giving
whatever these dots, these are the alignment patterns. Okay. Again, as I explained the fabrication flow, patterning is very important. Okay. You can't randomly locate or read the metal plates here and there. So first you have to keep the identification of the plates. The tool doesn't know where the plate it is, so you have to make sure that my plate is here, and you have to go there and you have to do the patterns. That command you have to give. But since it is not a command based, so how you will do that? You will make some patterns using these plus signs. Okay, around each and every plate, around you will be seeing 4 alignment marks like this. So once this alignment marks is fixed, and if you load into the EVL tool, then automatically it will go and pattern around this within this alignment marks. Okay, within this alignment marks, it will go and it will pattern the metal pads or whatever the pattern you want. The pattern you will do on that plate based on the alignment marks. That's why you will be seeing there everywhere that plus marks will be there, and this dots is like the pattern which they have made. Whoever made that device, I don't know purpose of what is the purpose of that, but they have made that. But usually these alignment marks you will see everywhere. This place. 1, 2, 3, and 1 will be above.
So that those places places right?
Those places they will make the plates.
So now in this pattern, the symmetric pattern,
Yeah.
So it's EBM in the metal.
EBM will make the pattern. Okay, you will make this pattern. After making this pattern, you go for metal deposition, then lift off. Then ultimately you will be left off with this pattern. Gold deposited.
2D material is
2D material is here.
but what you said clearly the flake is
No, we have done etching, right?
you achieved the
You etched and you made it regular rectangular pattern, then you made the patterning and everything is done. Okay. So this is how it is done. So then again you have to make this triax cables and you have to connect it to SMU. So you have to make sure that your cable length and which SMU to which SMU your cable has to connect it to which SMU. Because if you drag this rope without looking at there, then your probing will disturb and it can drag your sample also. Your metal pad also you can drag.
so we two you collected it
Only one.
time. So what happened
We are not doing device calculation, just simply checking binding characteristics of metal.
actually in the months are to find out
Sure.
no, this is not
100 millivolts, that is been 100 milliamperes. That's been explained in today's class. You see that there is the limit for the current. You have to limit the current or else it can damage the device later. So this compliance will be depending on which device we are operating. Simply they will provide 100 milli as a basic for SME whenever you take it. So the slave, that is SME 3, and making it as constant I volt 0 volts, giving the 0 volts with that, then go to display. In the x-axis you can select V1 because you are getting V1. You have to identify the I1. Axis. You can say I1. If you want to look into the Excel sheet or if you want to look into the values in the text format, then you can add the list display also here.
this is simply a metal.
Yeah, simply. Then you can linear data. You can run it and there is something varying from 0 to 1 volt. It is increasing, but as is shown that if it is crossing that limit, whatever we have given 100 milliamperes, it won't allow the current to pass through the device. So it is
X-axis
x-axis is voltage, y-axis is your current. 100 degrees, yeah, 100 degrees. So whenever it is crossing that beyond the voltage, then it will just saturate the current and it won't allow the more current to flow through the device. It's just simple linear behavior. And you can see the difference here. So whenever you are applying voltage, you can clearly see that metal pads will be slowly it will be getting damaged if you are providing higher voltages. And you can observe also if you do multiple 3 to 4 times, 5 times, you will repeat on the same metal pad. Then you can see there will be color of the metal pad will be changed around the probe tip, and you will be getting some dotted bubbles. No, metal thickness it will be decided whenever we are doing the fabrication step. It will be decided there. Here it is 1 micron metal pad.
So 1 micron, how much voltage?
That depends. You need to see. You need to check it.
Yeah.
That's why it is provided. It's getting high.
You applied what 1 volt, right?
Yeah, 0 to 1. Last time it was around 10 to 15 times. So one of the metal pad was completely damaged. It's like the counts and different characterization. Like here you can take one here, measuring through threads. So probing will come from practice. That's the first thing. How we have to do the characterization, that will come from rigorous study. We have to do the rigorous study, like what provide, what voltage.
Which material?
It's gold. And different. Okay, so
right? So now we'll have feedback as well as evaluation session. So first we'll have just evaluation session. So first we'll give you the question paper. Just 10 minutes, just pick and return. That's it. So you multiple class question. I have shared, by the way, I have shared the content you got that, right? All the lectures by area I have shared. I also whatever slides I use, I will share in the WhatsApp group only. So first, after the evaluation, we have formal feedback sessions, in which what we have you keep there must be one feedback on user, right? If you have three. Okay, fine. So you the feedback problem. How many of you have the feedback problem? You don't have it. None of you. Okay, fine. So I will so what will do? After the evaluation session, we will have some common feedback. If you have to say something about the event, you can say this year your experience, and then you have to say suggestion. You can give the suggestion. Then meanwhile, I will print the feedback form and I will give it to you. So then you can. You have some feedback form? Feedback you can give later. First, evaluation exam, then you can give feedback. Fine. So, feedback you can give later. First, give the evaluation exam. So, evaluation exam we just take around 15 minutes time. You have to think and just return to your class. You have to do that. And if they think of think that it's multiple choice question, just return. So let's give it a big round of applause. So before calling her for her so that she can say a few words. So I'd like to thank all the participants and other things for this event. So I'd like to thank start to IT Hyderabad who helped us in reviewing the proposals and approvals things for this GAN program, and thank you for the Ministry of Education who approved the GAN program. And of course, I would like to thank the reviewers. Name I don't know, but thank you. They have reviewed our proposals and they accepted that. Moving forward, I would like to thank Dean R&D IIT Dhanbad, especially the associate dean, Professor. So he helped in the approval of proposal submission and revisions and other things. So thank you, our associate dean, for helping all those things. Then I would like to thank Professor Ariel from T02 University, Israel, who was our guest faculty. Actually, he came in this very tough time. Actually, when the time I was communicating with him, that time the war was going on in Israel. It was very difficult for him, but still he agreed to come here, and he came here and he delivered lecture for today. Unfortunately, he did not speak for the package, but I hope you all have wonderful experience with him. Then I would like to thank HOD, our Department of Electronics Engineering, who will help in the building the logistics. Moving forward, I would like to thank Flexwing History Center, who gave us the center for organizing this program here. And special thanks to Devnarayanji, who helped in taking all the approval of this hall. Then we had the session started with the inaugural session. So special thanks to our deputy director, Professor Neeraj Kumar, our dean sir who came here, our associate dean sir, and our HOD. Those were here and those helping making the inaugural session a grand. Then we had hybrid programs with different sessions. We had total 9 lecture sessions, and we have basically 5 2-hour tutorial sessions and 10 1.5 hours lecture sessions, where we cover the different aspects from growth to the application of 2D materials, device, processing, and then you all have hands-on experience On quantum ETK, you have hands-on experience on the stamping stage, you have hands-on experience on the basically device characterization. Thank you our industry partner who helped in giving the hands-on experience like AIML, basically the integrated microsystem, and then today the LMAC and T-site people who have been getting the hands-on experience. Then I would like to thank our sponsors, especially their sponsors, the food partner, LMAC, and the basically LMAC with the authentic distributor of the T-site. Then I would like to thank all the participants who came different corner of India. So basically, I would like to give a big stat about the participants. So we have total 52 registered participants for this event. In that, 13 were from the outside of the institute, and of course 28 from the our campus. Among that, 41 participants turn out who visited this for this program. Among that, one participant from IIT, so that was from IIT Bangalore, we have participants from IIT Hyderabad, IIT Delhi, IIT Bombay, IIT Sikkim, SRILT Lucknow, AKTU Lucknow, BNMW Bihar, Galgoria University Noida, and of course IITS in Mumbai. So we had participants from different institutes who came here. So thank you all to all the participants who came here especially for the exam time and you gave valuable time here. I hope you had some quality experience with this event. So that we have already discussed in the feedback. Obviously, if you want to give the feedback, then give the feedback. And after that, for the regulatory session, also I would like to thank the man, our Dean CEP, T02 who came here and ready to give some valuable time. And last but not least, I would like to thank all the volunteers who made this program very, very successful. And I hope we'll be able to manage to be successful program in the future. Finally, I would like to thank all our faculty colleagues, our students who helped in different aspects in the whole execution of this program. So on this note, I would like to invite our esteemed guest, Professor T02, to say a few words about the program.
Thank you, Professor Kumar. Really, it's my privilege to see all the happy faces who are learning for last 5 days itself. So very good afternoon, my faculty colleagues and dear participants. It is our privilege to host you who are from outside. Our continuing education program is responsible for providing learning facilities beyond the classroom. You know, every day you used to learn, starting from our birth to till our death. So we learn every day, but the learning will be different. Like out of the whatever you are learning day to day, you are practicing beyond that also. For development of the society, we need to learn so many things, technical things, non-technical management skill. We need to develop. So our DCP office is responsible for offering those courses which are not being taught or taught differently in the classrooms. So we offer courses for the young youths. Even from the school, we'll start the courses for them also, for better learning, for skill development, for the executives, and for students like you also, for enhancing your knowledge here. So I'm happy that Professor Jivesh Kumar has offered these courses to GAN program to the material. That's very important for because we are moving through the electronics age only. No, nothing is possible beyond the electronics. So I hope that you have learned a lot and you will carry whatever you have learned from our external faculty from Israel. Because as Professor Jivesh Kumar mentioned that. Even the war is going on there also, he had found time to come here. We had also invited one faculty for a Spark program. He agreed initially, but he didn't come because of the war and living their family there itself because it is difficult for them. But Professor Ariel had come to teach you. So I hope you have learned. So thank you very much and happy journey back to you who have come from different IITs and different other institutes. Thank you very much.
It's time to distribute the certificates. We have to evaluate your performance in the exam. So now I would like to call main again to come forward and help in distributing the certificate. So participants, I will call your name one by one. If you please come forward, you can take the certificate. So, Akram. Mohammed Akram. Mr. Pramod Chaurasia. Mr. Pramod. Mr. Afjal. Mr. Gufran. Mr. Roshan Kumar Singh. Mr. Zurgesh Gupta. Mr. Pawan Kushwaha. Mr. Pawan Kushwaha. Mr. Tanmay Samanta. Mr. Tanmay. Mr. Amit Raj. Dr. Salim Said. Dr. Salim, please come immediately. Mr. Jafar. Ms. Aisha Rahman. Ms. Aarti Kumari. Mr. Soumik Chaudhary. Mr. Swastik Kumar Sahu. Rohan Gupta. Please come fast. Mr. Swastik, please be here. Dr. Rajini Bala. Sudesna Hemram. Mr. Nimin K. Nimin. Divagar S. Divagar. Alvira. Soumya Kumar. Shani Kumar. Pampas. Pratap Singh. Vikram Singh. Abhinav Balok Verma. Abhinav Balok. Okay. So Dr. Manas. Devnar is here. Devnar. Yeah, so thank you, man. So please, oh, you are there. You're not there. I'm not there. You missed your chance. Yeah, Dr. Salim Sai. Few more participants. Prashant Jha. Prashant Jha. Utkarsh Kumar Mahi. Harsh Kumar. Harshvardhan Naidu. Farhad Khan. Abhinav Balok Verma. So now I would like to call Dr. Rajani Bala to come forward and participate.
Thank you. Felicitation. Our job is to do felicitate this. So, but anyway, thank you very much. This is your regular office job, no?
So, final time for this 5 days Gyan course. So, finally, I would like to thank our faculty colleagues, Professor Amitesh, Professor Jaising, Professor Govind, Professor Jitin, who all came here and attended this final calligraphy session. So, thank you to all the participants coming, and I hope once you will organize some kind of event in future, then you all will join and you will take the benefits. So, all of you please keep in touch for further program. Finally, thank you, man, for coming. Thank you. So, snacks is waiting outside. So, if you come, have snacks. But before that, I would like to. And please take the LSAT stand also. Somebody please give mobile.